Okay. So what we're going to be doing is we're going to be solving one of the Mobius questions today. And what we want to start doing here, basically what it asks is what is the slope at x equals to 1, right? So what we're going to be doing is we're going to see that we can't really isolate for x or for y. And because of that, what we're going to do is we're going to implicitly differentiate this to begin with. Okay? So what we do is we're going to take dx on both sides. So we're going to go x squared plus y squared minus 4x squared equals to 2x squared plus y squared. Oh, and dx on the other side too, of course. Dx 2x squared plus y squared. Does that make sense?
Yep.
Then what we're going to do is we're going to start deriving it basically. Here we have a square. So then we're just going to, as I said, we're going to start deriving. So over here, we're going to have a chain rule. So the first thing we're going to do is we're going to bring out the 2. So it's going to be 2x squared plus y squared minus 4x squared. And that's going to equal to, and I'm rushing, times, so we need to chain it. So the derivative of x squared is going to be 2x. It's 2x times y squared. Now y squared we're going to implicitly derive, so it's going to be 2y. And then we're going to chain it to the derivation of y. So times dy over dx minus 8x. Simple enough?
Yeah, let me just stop you because I think you accidentally added a square root over the negative 4x squared on the line above.
Is it not negative 4x squared? Oh, it's just negative 4x. Perfect, thank you. So then it's just going to be negative minus 4. Okay, great. Now we're going to continue. So then when we're deriving, we can get constants out. So it's going to be 2 times, we're going to derive x squared. So it's going to be 2x. And we're going to derive 2y. So it's going to be plus 2y. And then we're going to chain it to deriving y itself. So that's going to be dy over dx. And there you go. We have our line. Now comes the tedious part with a lot of mistakes. I already made some mistakes, which is funny. But now we just have to expand everything and simplify, or to be more exact, isolate for the variable dy dx, because this is what's going to give us our tangent. So if we can get dy dx on one side and everything on the other side, we're going to have some equation or you can even say some function that tells us what our tangent is. Cool? So let's start carefully deriving. Not deriving, isolating. So let's just open brackets on our left side first. So we're going to get 2. So firstly, what I'm actually going to do to make my life easier for myself is I'm going to cancel out these 2's over here. Now we just don't have to expand it. Now I'm going to start expanding. So we're going to get x squared times 2x. So it's going to be 2x cubed. Then what I'm going to do is I'm going to multiply it by this. So it's going to be plus 2 squared over here plus 2 x squared y dy dx minus 4x squared plus 2xy squared plus 2y cubed times dy dx minus 4y squared minus 8x. This is supposed to be a plus. Minus 8xy dy dx plus 16. Make sense?
Yep.
Perfect. Then on the other side, the expansion is quite easy. We're just going to open the brackets. It's going to be 2x plus 2y dy dx. Okay. quickly, what I'm going to do is I'm going to run through and just try to simplify it as much as possible, see if we have any like terms. So for now, the only like terms that I see, let's pick green. The only like terms I see is these two. And that's it. No, there should be one more. Minus 4x squared. And then negative 4. So this is supposed to be x squared, actually. This is supposed to be x squared. I apologize, because negative 4x times 2x is going to be negative 8x squared. Does that make sense?
Yep.
Okay, so now, again, I'm just going to I'm going to do two things right now. The first is I'm going to bring over, as part of me trying to simplify, I'm going to bring this, and this over to the other side so that later on we could get rid of dy dx. Like we can take it out of the brackets, dy dx, and then I'm going to bring 2x over to this side. So rewriting everything, we are going to get 2x cubed, then minus 4x squared minus 8x squared. 4x squared minus 8x squared is going to give us minus 12x squared, right? 12x squared. Then it's going to be minus 12x squared. That is going to be plus 2xy squared. Plus 2xy squared. Minus 4y squared. So 4x and 8x are accounted for. Plus 16x. Cool? Plus 2x. Minus 2x to be more exact. Minus 2x from the other side. Make sense?
Yep. All good.
The question becomes who's teaching who right now? Or who's helping who? Okay. Then on the other side, we're going to get 2y dy dx plus 8xy dy dx minus 2y cubed dy dx minus 2x squared y dy dx, right?
Yep.
Now what we're going to do is, I see that all of my terms have a 2 in them. I'm going to simplify by another 2 just to make my life easier. And then I'm just going to write this step to the side because I don't want to rewrite everything. So this, what would happen, I'll do it in red quickly. What will happen is that I can take dy dx out of the brackets. So I'm going to get dy dx times, and again, we're going to simplify everything by 2 later on. But it's going to be, right, just for now, it's going to be 2y plus 8xy minus 2y cubed minus 2x squared y. Okay, then what we're going to be able to do is we're going to be able to take this and we're going to be just put it under what we have on the left side to isolate for dy dx. Okay, so what I'm going to do is I'm just going to do this. I'm going to control C. I'm going to move it over here. Then I'm going to control V. Perfect. Shriek. Control V. Perfect. So I'm going to put it right here. And just for fun, let's continue writing with red marker. So everybody's confused why we switched. So it's going to be 2x cubed minus 12x squared plus 2xy squared minus 4y squared plus 14x. Cool? Equals dy dx, right?
Yep.
For our final step, and again, I know this part isn't conceptually hard. I will explain the conceptually hard part in a bit, but we need to get to the conceptually hard part. We need to complete this first. So then what we do is we're going to simplify all the 2's just to make it a bit easier for us in the future as well. So this is going to become, it's going to become x cubed minus 6x squared plus xy squared minus 2y squared plus 7x over y plus 4xy minus 2 minus y cubed minus x squared y, okay? Equals dy dx. And then just one more simplification, just because we want to, because I love writing. X cubed minus 6x squared plus xy squared minus 2y squared plus 7x equals to dy over dx over, and all I'm going to do is I'm going to bring out y out of the bracket. So it's going to be y plus times 1 plus 4x minus y squared minus x squared. Bam. Cool. We happy with this?
Thrilled.
Right. Now, I'm going to bring it over to something much easier to explain concepts, okay? And I'm going to bring it over to something that hopefully we're all familiar with. It's the equation of the circle, which we reviewed today in class as well. But for everybody who doesn't know, the equation of the circle is x squared plus y squared equals to 1. And this is a unit circle with a radius of 1 centered at the origin. But we don't really care right now. This is just a circle. Now, what we want to do is we wanted to figure out the tangent, or how we could get the tangent of the circle. So again, for here, we would need to implicitly differentiate. Hopefully everybody knows how to implicitly differentiate, especially with what we just did, that massive thing. Very exciting. So this should be a breeze for us. So dy over dx is equal to x squared plus y squared. It's not dy over dx, it's just d over dx equals to 2x, so equals to d over dx of 1, and this can just going to be 0. So we're going to get 2x plus 2y, chain it to dy dx equals to 0. We're going to simplify this to 2's. We're going to get dy over dx equals to negative x over y. Perfect. Now, what does this tell us? Well, this tells us the tangent of the circle. But what's really special here is that usually when we were looking for tangents, right? So if we just have a parabola, for instance, a very simple parabola, x squared, right? When we're looking for this tangent of x squared, we differentiate it, so we get dy over dx is equal to 2x. And then when we need to get the tangent at a certain point, all we need is an x value. So I can ask you, well, what is the tangent at x equals 1? To that, you could reply, well, you just plug in x, the x value into 2x to get the tangent. So you would get dy over dx equals to 2. Does this make sense? So you know that the tangent at 1 is 2.
Yep.
Now, the hard question becomes, well, now we don't only have one input. We have 2 inputs. The first is x, and the second is y. So if the second input is y, then what we're going to do is when we are calculating for the tangent at a specific point, what we're going to need is we're going to need both the x coordinate and the y coordinate, right? So then let's say we have a circle. So there it is. I'm going to draw a beautiful circle. It's not going to be centered at the origin because there's no such function here, but it's more or less a circle. There it is. I'll try to center it a bit more. It is an ellipse. We're going to pretend this is a circle. I'll even just put it circle for fun. So now that we've got our fun, let's go back to the math. So now if I want to find my tangent, for instance, of the circle at x equals 0.5. Well, there are two problems here, and we're going to see. So the first problem is that now we can't just plug in x equals 0.5 over here. Why? Because we have another input that we need to get that tangent. So the question becomes, how do we find that input? Well, the answer is actually a lot simpler than we would think. Because if we're looking for the x coordinate and we know it's 0.5, then we can easily find the y coordinate. How do we do that? Well, we have the function right over here, right? So if x is equal to 0.5, then y is just equal to, and we're just going to plug it in and solve for it. So we're going to get 0.5 squared plus y squared equals to 1. Y is equal to square root of 0.1 minus 0.5 squared. And this would be our y input now. And important to notice that because it was squared, it was plus or minus. And we're going to explain why there's a plus or minus here in just 1 second. So now that we have our two inputs, what we can do is we can finally find our tangent. So how would we find the tangent? Well, now we would just plug in both of our values, and then we would be able to find the tangent. So we would get dy over dx is equal to negative 0.5 over, that was a hideous 5, but I always have hideous 5s, over square root of 1 minus 0.5 squared, because that was our y input at that point. And then the answer for this would in fact give us the tangent at our point of 0.5, so 0.5, and whatever y is somewhere over here. And we would get our tangent. What color do we like? We like orange, so we're going to get our tangent right over here. But then you could be saying, but Ruben, how did you find, well, you said before that we have two values here. How do you justify that? Well, if we think about it, because this is a circle, actually, what's gonna happen is that for one value of x at 0.5, we're gonna get two values of y. And in this particular case, it's not that just two values of y, the positive and negative, but at these spots, the tangent will actually be the exact same, but the only difference will be whether it's going to be the reciprocal of each other, and because of the negative. So here, the slope is going to be the same. It's just going to be negative. And that is a terrible slope. So I will try to adjust it to actually make it tangent. There it is. That's a bit more tangent. And that is expressed actually because in our second case, dy over dx equals to negative negative. So it'd just be 0.5 over square root of 1 minus 0.5 squared. Does this make sense?
Yep, all good.
You sure?
Yeah, just, are you using the actual values from the question now or just explaining the?
Right now, I'm just trying to explain why we have two values, x and y, and what the hell's going on.
Okay, I was just confused with the two, but since you're using arbitrary values, it makes sense.
With the two, what two?
Like, sorry, 2x, but I just see that you're using x squared as an arbitrary value, so it's okay.
Wait.
All good. Don't worry.
This is something else. This was about the problem. No, please don't apologize. And then two here. This was just the circle, and I was trying to explain what to do with the circle. Does that kind of make sense?
Yep.
And then we get two values because when we would get two tangent lines, and that's why for x equals 0.5, there are two different tangents that we would get at that point.
Right.
Okay.
Yep.
Now going back to our problem. Yay! What a nice little equation we have here compared to our other one. What we see now is that what do we have? We have 1 point. That 1 point, if we remember, or to be more exact, our x coordinate was x equals to 1. But just as we saw it before with the circle, in this case, because we have two values, right? I'm going to use red and green until Christmas passes. So we have x, and at the same time, we have y. So just x isn't enough. So what do we need to do? We need to find the y values at the point for the function where x equals to 1. And we need to find all of them. Because as we saw with the circle, if there are multiple y's, that means that for one value of x, there are different there are multiple different y's that exist, and for each one of those, there's a slope. And that's why we need to find the y's. Now, if we go back, so how do we do that if we remember? What we do is we go back to our original equation and we plug in x and we try to isolate for y. So let's go back to our original equation all the way over here. And now what we're going to do is we're going to put in x, and then we're going to start isolating for y. So let's go right over here. Let's post it here. Perfect. And now we're going to plug in x where x is equal to 1. And we're going to try to isolate for y, as I said, 3 times. So let's plug in x. So we're going to get 1 plus y squared minus 4 squared is equal to 2 times 1 plus y squared. Okay, so now we just need to expand everything and then bring everything to the same side. So then we're going to get y squared minus 3 is equal to squared is equal to 2 plus y squared. Then we're going to expand the left side. We're going to get y to the power of 4 minus 6y squared. This is 2y squared. I apologize. I just forgot to multiply it in. Minus plus 9 equals to 2 plus 2y squared. Now I'm going to bring over everything to the left side. We're going to get y to the power of 4 minus 8y squared plus 7 equals to 0. And if you're from BME, then you would recognize this as one of the simplified equation he gave to us for in the question. And he just got this from simplifying this. But now from here, we need to find all the values of our y. And what we're going to see is we're going to get 4 values of y. But otherwise, this is just a quadratic equation. The way you can think of it as a quadratic equation is you can say let y squared equal to let's say z, and then here we can replace all of our values of y squared into z, and we're going to see that it does in fact turn into a quadratic equation. So if we replace all our y's with z, we're going to get z squared minus 8z plus 7 equal to 0. Then we just find our z's. So here we can factor easily. We're going to get z minus 7, z minus 1 equals to 0. So now we get our 2 values of z. So z is equal to 1 or 7. But let's remember, we're not looking for z, we're looking for y. So now we got to go back to y and figure it out. So the first option is y squared equals to 1. Y is equal to plus or minus 1, square root of 1. Then the second is y squared equals to 7. Y is equal to plus or minus root of 7. Any questions about this part?
All good.
All good? Perfect. So now we have our values of y. Let's grab them so we remember them. With that horrible, horrible 7, I will erase it when I get them. And put it
It
here.
has personality, the 7. Personality.
Personality is something we like. So we're going to post it here. And we're going to move it. No, shrink. Post it here. Perfect. So now we can see all our values of, and I'm going to delete my personality so others can get it. I'm going to put a normal 7 here. There you go. As normal as it can get. So now we can party. We can celebrate because we have both our values. We know that x is equal to 1 and y is equal to, and then we have our 4 values of y. So what I would recommend doing is before plugging in everything, first I would just plug in x because x is a very simple value and we're going to simplify our expression a lot. And then we can start plugging in our y's. So let's do that. So we're going to see when x is equal to 1, because we know x is going to stay constant at this point. It's always going to be 1. It's going to be the y's that we're switching in and out. So if we plug in x equals 1, we're going to get 1 minus 6 times 1 squared is 6, so minus 6 plus y squared minus 2y squared plus 7. So then what we're going to get, we're going to get negative, oh, and on the bottom, How could I forget? We're going to get y times 1 plus 4. 4 minus y squared minus 1 equals to dy dx. Then I'll just simplify to the side, so then later on we could grab it again. So then if we just simplify it, we're going to get y squared minus 2y squared is negative y squared, negative y squared. Sorry, I just have a feeling that I messed up somewhere for some reason. Are my negatives correct? Where did I get negative 4y squared from? Negative, okay. Let's hope that everything was correct. Okay, we'll see. Okay, negative y squared. And then plus 7 plus 1 is 8 minus 6 is 2. So negative y squared plus 2 over y times, it's going to be negative y squared. Negative y squared. Plus 4 equals dy dx. Cool.
Cool.
So now comes the fun part. We're finally getting to our solution after X amount of minutes, or we don't want X, after a happy amount of minutes. So we're just going to start plugging in our y's and seeing what our slope is. So for y equals 1, we're going to get negative 1 plus 2 over 1 times negative 1 plus 4, which is equal to 1 over 1 over 3, right? Now the next thing we're going to do is the next solution is with negative 1. So we're then, if we have negative 1, we're going to get negative 1 plus 2 at the top again, but at the bottom we're going to get negative 1 plus 4, and then we're going to equal negative 1 over 3. Make sense?
Yep.
We're almost at the finish line. All we have to do now is we're going to have to plug in values of plus or minus root 7. So let's do that. So if we plug in the value of root 7, I'm going to start with positive. So it's going to be negative root 7. Negative root 7 squared is just 7. So it's going to be negative 7 plus 2 over, that's going to be root 7. It's going to be root 7 times y squared. So it's going to be negative 7 plus 4. And that is going to be equal to, on the top, we're going to get negative 5. So negative 5, negative 5. It's going to be equal to negative 5 over negative 3 root 7. So that's going to simplify then. Our positives are going to cancel out. Our negatives are going to cancel out. We're going to get 5 over 3 root 7. Finally, last step, we're almost at the finish line. We're going to plug in negative root 7. So it's going to be negative root 7 squared is still going to be negative 7 plus 2 over negative root 7 times negative root 7 plus negative root 7 squared, I mean, so it's negative 7 plus 4 equals to negative, so this time it's just going to be one negative, because, so it's going to be negative 3 times negative root 7, so it's going to be negative 5 over 3 root 7. So in the end, we see we have 4 solutions. The solutions are 1 over 3 for y equals to 1. We're going to get negative 1 over 3 for negative y equals negative 1. 5 over 3 root 7 for positive root 7, and negative 5 over 3 root 7 for negative root 7. Any questions?
None. That was so good. Thank you so much.
Okay. Thank you as well. and then I will stop recording. Hopefully this helps everybody.